Good morning. Am I audible? Can you hear me?
Yes, ma'am.
Yeah. So we'll start off the class. I'm on mobile data, so I've kept my video off. So torsion of shafts. We have learned the concept in the previous class. We will quickly do 1, 2, 3, 4 problems today. Okay, with respect to what we have learned in the previous class. And on Wednesday and Friday's class, yeah, I think we have 2 more classes. So Wednesday and Friday's class, we will take the other topics, springs and double shafts. Okay, so I want all of you to read the question. I write down what all is given and what is asked in the question. Okay, so similarly, even I'll be doing the same. I hope you have your notebooks with you. Please start writing. Just write down what is given. So the question number is given. It's taken from Bansal textbook. You have any doubts? If you have network issue or anything, please refer the textbook. Otherwise, just follow me. So two shafts of the same material and of same length are subjected to same torque. The first shaft is a solid circular section, second is a hollow. Alright? Whose internal diameter is 2/3 of the outside diameter. So same material, same length, same torque. One shaft is circular section, another one is hollow. And internal diameter is given as 2/3 of the external diameter. And maximum shear stress developed in each shaft is also same. Compare the weights of the shaft. Okay, so we will take torque as T, and then you have shear stress. Outer diameter of the solid shaft, D naught, Di, and then Ws as weight of the solid shaft, Wh, weight of hollow shaft, length of each shaft is also same, so let's take it as L. So only the weights are differing. Okay, and both are same material, so the weight density also remains the same. Okay, so if you see this slide, what does it say? So if you see the slide, torque is same, shear stress is same, the diameter of the solid shaft, diameter of the hollow shafts are different, so there are 3 different variables we're going to take. Weight of both the shafts are different, so we're going to take 2 different variables. Length of each shaft is same, both are same material, so the weight density, Young's modulus, everything is going to be same. Okay, so make a note of it, and I'll shift to the iPad now. Okay, I'm going to stop sharing. I'm going to go a little fast in today's class because of lack of time. Okay, so please bear with me. If you have not written down, take a screenshot. I hope you're able to see my screen. Yeah. So that is what is given in the problem. We need to find out WSM, WH value. Okay, so how are you going to solve this question? First of all, write the 2 equations for the solid and the hollow shaft. Okay, so we know T is equal to pi by 16. Please let me know if I'm not audible, if my video is off. Okay, if it is not clear, Please let me know. Okay. And we also know T is equal to pi by 16 for a hollow shaft. This is the formula. Clear? Okay. So if you reduce this value, please substitute shear stress, and we know that Di is equal to 2 by 3 D naught. All right. So let's substitute that. So if I substitute it here, it's going to be 16 by 81 D naught power 4 by D naught. Okay. And if you solve this question, it's going to be pi by 16. This will be 65. Oops. 65 by 81 D naught power 3. Okay, this can be equated to pi by 16. Okay, so you can cancel these. All right, and finally you will get 3 power 3 as 65, 81, 3. All right, in other terms, D equal to, if you solve it, do a cube root on both sides. Okay, and the decimal is going to be D naught. Okay, so this is the first equation that we get. Please let me know once you've written it down, and I'll go to the next part of the question. This chapter is again very simple. Done? You guys can, if you have any doubts, you can ask me. If you're done, let me know. Joel?
Yes,
Richard? Done? Okay, let's proceed to the next question, next part of the question. So the next part is, let's calculate the weight. Okay, so what will be the weight of the solid shaft? Weight of the solid shaft. Okay, I'm not writing fully weight of the solid shaft. So first thing is, you have the weight density multiplied by volume of the shaft. Correct? Okay, what is volume? Area into length. So area of section, okay, multiplied by length. All right, so you have, what is the area of the cross section for a solid shaft? Pi by 4, it's a circle, right? D square multiplied by length. What about WH? The same formula. So W, weight density remains the same. Pi by 4 D naught square minus Di square. Again, length is same. Okay, so substitute the value of di, it's given in the problem. So you have 4 by 9 d naught square multiplied by L. Guys, if you have any doubts, you can please ask me. Okay. 5 by 4 multiplied by 5 by 9 d naught square into. So we need to find out what is the relationship between weight of the solid shaft and weight of the hollow shaft. So I'm going to divide both of them and get the ratio. Okay. So substitute all this. It's very simple. If you guys have any doubts, please let me know. So cancel. All right. So we know what is D. D we can substitute as 0.92. We have 9 by 5 and 0.929 square d naught square by d naught square. So this gets cancelled. So you will get an equation. If you solve this, you will get, so WS shaft is 1.55 times weight of the hollow shaft. So the hollow shaft will be obviously lighter. Okay, so that's the answer. If you have any doubts, please ask. You guys are done? Class, please respond.
Yes, sir.
We go to the next problem. So this is the next problem. A hollow shaft. Yeah. A hollow shaft of external diameter 120 mm transmits 300 kilowatt power at 200 RPM. So diameter is given, power is given, RPM is given. The internal diameter, the maximum stress in the shaft of XC. Maximum stress is also given. We need to find out what is DI. Okay, please write down what is given. All right. I suppose all of you must have already written it down. Okay, so we need to calculate what is internal diameter. All right, so we know what is, so we have converted P in watts. So the formula that we had used, this is a simple formula that you guys already know, 2 pi n T by 60. So equal to 2 pi. So with this, we can calculate what is torque. Please solve. Tell me what is the answer. So you will get the answer in Newton meter. Very important. This is the point here. You will get the answer in Newton meter. So which you have to convert it in Newton mm. What did you get? Those of you who are done, you can proceed with T is equal to, you need to calculate DI. So we know this equation. Yeah, so substitute all the values. We know torque, shear stress is given, D naught is given. You just have to find what is DI. So please solve. I'll give you 5 minutes. If you have any doubts, you can ask. What is the answer, guys? Jason, Tom, Vishnu, please respond. Use the chat box. Nathaniel, Vigil, are you guys there or not?
Yes.
Yeah, what's the answer? Tom, Nicholas. What about Jason? You guys take so much time to solve this. Avikash,
Yes, ma'am.
what's the answer, Avikash? Are you solving?
Doing
2 more minutes. Anyone who's got the answer can answer. Give the answer.
0.088 meter.
That is DI. DI?
Yes, ma'am. 88 millimeters.
Okay, let me check. Yeah, correct. Okay, so you must have got 14,323.9. So if you want to convert this into, you need to multiply it by 10 power 3 into mm. Okay, so you will get 14,323.900. Okay, so you need to substitute this here. Substitute it here. So you will get those of you doing, I'll just solve in 2-3 steps. So you should substitute like this. Okay. Pi by 16. This shear stress 60. Then you have 120 power 4 minus di by again 120. Sorry. Okay. So we can take pi by 60 to the other side, 60 also to the other side, and 1 as well to the other side. So you will get di power 4 equal to around okay, multiplied by 120. So this I'll just cut 20786 minus 145,902.00. So you'll get 154. So finally, yeah. So please take a screenshot. We'll proceed. It's 9:30. We have 2 more problems to solve. Okay, so I'm just gonna stop sharing and share the question. So the next question is 16.10. Okay, a solid steel shaft has to transmit 75 kilowatt at 200 RPM. So power is given. Okay, so here power is given as 75 kilowatt. So 7500. Please write it down. Okay, I'm also writing. And RPM is 200 RPM. Taking allowable stress, so shear stress is given 70 Newton per mm square. Find the suitable diameter of the shaft. So you should calculate what is the diameter. What else is given? If the maximum torque transmitted by at each revolution exceeds the mean by 30%. So what does that mean? Your torque maximum, it says maximum torque. Okay, so write it as T max is equal to, it exceeds by 30%. So it's not 0.03. It doesn't say that the mean maximum torque is 30% of the mean. It says it exceeds mean. So 1.3 multiplied by T. Okay, so what is T here? T is nothing but mean torque. Okay, this is what is given in the problem. You need to calculate what is D. So let me just share my iPad screen. So this is what is given. Can you see my screen? This is what is given. Okay, so you have to be very careful. It does not say it is 30%, does not say it is 30% of mean torque. Okay, it says it exceeds mean torque by 30%. It's not saying this, it's saying this. Okay, that's why I've taken 1 point. Okay, again, it's pretty simple. P is equal to 2 pi nt by 60. Okay, so if you substitute the values, 75 into 10 power 3, 2 pi n 200 into t by 60. So you will get t as 3580.98. Okay, you can check it up. If you convert this into mm, Newton. So now T max is 1.3 torque. Okay, so here you have to substitute the mean torque value, and finally the maximum torque here is 4,655,274 Newton mm. Okay, now this value you are supposed to use in your torque equation. So the torque equation, it's a solid shaft, so you have T max is equal to pi by 16 shear stress d power 3. Calculate what is D. I think you can do it. Please solve. Please solve, everyone. I will write the answers here, because we still have one more problem. We cannot take it to the next class. Okay. Please make a note of it. I'll give you a minute, or take a screenshot. No problem. Done? Can I proceed to the next question? Guys, take a sleep.
Yes, ma'am.
Okay. So this is the last one for today. Then I'll take attendance. Okay. Determine the diameter of a solid state shaft which will transmit 90 kilowatts, convert into watts. Okay, at 160 RPM. So N is 160 RPM. You need to determine the length of the shaft. If the twist must not exceed 1 degree over the entire length. So theta value is given as 1 degree. Please convert it into radians. So theta by 1 degree. Okay, pi by 180 will give you radians. All right. The maximum shear stress is limited to 60. Shear stress is given, guys. Modulus of rigidity is given. Okay. We need to determine what? The diameter and the length of the shaft. Okay. So please write down the what all is given and also write down. Okay. Can you see my screen? Okay, so the same procedure. Let's calculate D first. So how do you calculate D? I will not solve the whole thing by 60. So you will get, you can substitute P, you can substitute P is going to be 537,148 Newton meters. You can solve later and check whether you're getting the same answer. So this thing has to be converted into mm. Okay. Now next is T is equal to pi by 16 D cube. So with this you can easily calculate what is D. Okay, I will not solve. You are going to get 76.8 mm. Now how do you solve the length? Okay, let me explain to you and then you guys can solve. Meanwhile, I'll take the attendance. So we know the torsion equation. All right, what is the torsion equation? We saw it in the last class. T by J, where is my screen? Yeah, T by J equal to shear stress by R equal to C theta by L. So if you use this equation, you can easily calculate what is L because shear stress is given, R is D by 2, C, and you already have theta. So can you solve that? Yeah, let's solve it. So shear stress R C theta by L. Okay, d by 2. So this I will solve. 60 d by 2 equal to C is, all the units are in Newton mm, so nothing to change, pi by L into 180. So pi is nothing but 3.14. Okay, with this you can easily calculate what is L. So 60, I'll write the final answer, you guys can do the maths. So you have 5 minutes, please solve. If you have any doubts, you can ask me. I will take attendance while you guys are solving. Yeah, please answer your attendance. UL1, Sridhar,
Present, ma'am.
Present, ma'am.
Ma'am, you alone present, ma'am.
yeah, Alan,
Present, ma'am.
Subhashram,
Present, ma'am.
Richin, Tom.
Present, ma'am. Present, ma'am.
Tom, are you solving?
Yes, ma'am.
Okay, Anthony,
Present, ma'am.
David,
Present, ma'am.
Calvin, Brian,
Present, ma'am.
Brian,
Present, ma'am.
Astel,
Present, ma'am.
Jacob, Evans,
Ebins present, ma'am.
Jacob, Praveen,
Present, ma'am.
Vishnu,
Present, ma'am.
Jerry, Daniel,
Present, ma'am.
Prashant, Mukesh,
Present, ma'am.
Mukesh,
Present, ma'am.
Ashwin, Rohit,
Rohit present, ma'am.
Abhikash,
Abhikash present, ma'am.
Tarun,
Present, ma'am. Tarun, present, ma'am.
Sam,
Present, ma'am.
Sriram, Arun,
Present, ma'am. Present, ma'am.
Sriram is present. See all.
Yes, ma'am.
Jason,
Present, ma'am.
Kristen,
Present, ma'am.
Akash, Febin,
Present, ma'am.
Balakrishna,
Present, ma'am.
Mohammed,
Present, ma'am.
Alex,
Present, ma'am.
Sam,
Ma'am, present,
Partha,
ma'am.
Parth, Ajay,
Present, ma'am.
Shaikh,
Present,
Jeffrey,
madam.
Deepak,
Present, ma'am.
Harsh, Sushil, Joel,
Present,
Richard,
ma'am.
Present,
Gibson,
ma'am. Present, ma'am.
Tirumala, Matun,
Ma'am, present, ma'am.
Gibson Sam,
Ma'am, present, ma'am.
Present, ma'am.
Am I audible? Can you hear me?
Yes, ma'am.
Yes, ma'am.
Yeah, I think I lost at Mithun,
Present, ma'am.
Gifton Sam.
Ma'am, 47 present, ma'am.
Okay.
48%, ma'am.
Okay. Aditya, Bharateja,
Teja present, ma'am.
I'm 14
Aditya.
present. Ma'am.
Okay. Aditya Krishnadas.
Yes, ma'am.
UT1 and UT2.
Yes, ma'am.
Bijil. Okay,
Present, ma'am.
absentees. So many absentees. 1 second. 11 absent. 18 is absent. 23 is absent.
I'm 23%,
28
ma'am.
is absent. Okay. 28 Akash is absent. 40 and 41 absent. If you've given your attendance, you can leave. If you have any doubts, I'll read it again. 11, 18, 28, 40 and 41 are absent. Okay? Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
See you on Wednesday. Most welcome.
Thank you, ma'am. Thank you, ma'am.
Ma'am, 11 is present, ma'am. He has mic issue.
Now you're telling me. I already marked.
Ma'am, number 11%, ma'am.
I already marked attendance.